Hello viewers, this video is about three-phase voltage source inverter in 180-degree conduction mode with star connected load. The circuit of the three-phase inverter is shown here, which consists of 6 switches S1 to S6 along with anti-parallel diodes D1 to D6. The switches are numbered in the order in which they are triggered, which means if S1 is triggered initially, then after 60-degree interval, S2 is triggered, followed by S3, then S4, S5, and then S6. The circuit consists of three legs. The midpoint of each leg is connected to the three terminals of the three-phase load. The circuit can be operated in 180-degree or 120-degree conduction mode. In this video, we are going to see the 180-degree conduction mode. In 180-degree conduction mode, at any time, three switches will be in on condition. The combination of the switches in on condition will be such that any two devices from either top and one from bottom can conduct, or any two from bottom group along with one from top group can conduct. And in 180-degree conduction mode, there will be conduction of three switches at any point of time. There are 6 modes of operation. In mode 1, which is S1, 6, S6 and S5 will be in on condition, and this mode will take place from 0 to 60-degree interval. Mode 2, in mode 2, S1, S6, S2 will be in conduction. In mode 3, S1, S3, S2 are in conduction. And in mode 4, S4, S4, S3 and S2 will be in conduction. In mode 5, S4, S3, S5 will be in conduction, and in mode 6, S4, S6, S5 will be in conduction. Now we will see each and every mode. Mode 1, in which S1, S5 and S6 are in conduction. We can see that the A terminal is connected to S1 to Vs. B terminal of the load is connected to S6 to Vs, negative terminal of the Vs, and C terminal is connected to positive terminal of Vs through S5. So we can see that the current will be flowing from A to O, and then from O to B, and then from C to O. So this circuit can be redrawn in the simpler manner as given in the right side. So since A terminal is connected to plus of Vs, A is connected to the plus of Vs, and the C terminal is also connected to the plus of Vs. So C terminal is connected to the plus of Vs, and B is connected to minus terminal of the Vs. So B is connected to minus terminal of the Vs. So we have drawn the star connected load in this fashion. Now, with this circuit, we can write the voltage across the terminals VAO, voltage across the terminals A and O, C and O, and B and O. So, since the current is flowing from A to O, the VAO and C to O, the voltages VAO and VCO can be written as Vs into R by 2. So since these two resistors are in parallel, the equivalent resistance of these two resistors will be R by 2. So we can use the voltage division rule to calculate the voltage VAO and VCO. So Vs into R by 2, that is equivalent resistance of these two terminals, divided by sum of the resistance, that is R plus R by 2. So which will give you the voltage across voltage VAO and VCO as equal to Vs by 3. And similarly, we can write VPO as the VPO in VP, the current is flowing from O to B. So VPO will be minus, will be having the negative polarity. So VPO will be minus Vs into R divided by R plus parallel combination of R and R, which is R by 2. So which is equal to minus 2 Vs by 3. So in mode 1, VAO and VCO, they have the magnitude of the voltage as Vs by 3, and VBO is equal to minus 2 Vs by 3. Then in mode 2, the switches S1, S6 and S2 are in the on condition. The terminal A is connected to the positive terminal of Vs through S1. So we have drawn the circuit such that A is connected to the positive terminal, and B and C, they are connected to negative terminal through S6 and S2 respectively. So B and C are connected to the negative terminal here, and the star load is drawn like this. So from here, we can see that the current in this R is flowing from A to O, and the current in B and C terminals, they are moving, that is flowing in the negative direction, that is O to B and O to C. So we can write again the VAO as equal to Vs into R divided by sum of the resistances, that is R in series with R parallel R, which is R by 2. So which is equal to VAO equal to 2 Vs by 3, and VPO and VCO, since the current is flowing from O to B and O to C, it is having the negative polarity. So which will be equal to minus Vs into R by 2 divided by R plus R by 2, which is equal to minus Vs by 3. Then this is a mode 3 in which S1, S3 and S2 are in on condition. A and B terminals are connected to the positive terminal of Vs, and C terminal is connected to the negative terminal of Vs, so which is drawn here. So VAO will be equal to VPO, which is equal to Vs by 3, and VCO is equal to minus 2 Vs by 3. And in mode 4, the switches S4, S3 and S2 are in conduction. B terminal is connected to the positive terminal of Vs. C and A and C terminals are connected to negative terminal of Vs. So which is drawn here. So VAO will be equal to minus VAO will be equal to VCO, which is equal to minus Vs by 3, and VBO will be equal to 2 Vs by 3. And in mode 5, the switches S4, S3 and S5 are in on condition. The terminals B and C, they are connected to the positive terminal of Vs, so which is drawn here, and the terminal A is connected to the negative terminal of the Vs, which is drawn here. So VAO will be negative, which is equal to minus 2 Vs by 3. VPO and VCO equal to plus Vs by 3. Then in mode 6, this is mode 6, in which switches S4, S6 and S5 are in conduction. The terminals A and B, they are connected to the negative terminal of Vs through S4 and S6 respectively, and C is connected to the positive terminal of Vs through S5, so which is drawn here. So the voltage VAO will be equal to VPO, that is equal to minus Vs by 3, and the voltage VCO will be equal to 2 Vs by 3. So we have obtained the voltages of 3 different phases for 6 different modes. So we can draw the voltage waveforms in this manner. So we have taken the switching pulses of these all the 6 switches here. So mode 1, in which 561 combination conducts. Mode 2, 612. Mode 3, 123. Mode 4, 234. Mode 5, 35, 345. Mode 6, 456. So again, it is going to continue. So let us take just one cycle and we can analyze the waveform. So from the 6 different modes, we have obtained VAO, VPO, and VCO values, magnitudes. So we have to draw the magnitudes of the voltages of different phases VAO, VPO, and VCO for 6 different modes for 6 modes. So if we plot all the magnitude of VAO, VBO, and VCO for different modes still from starting from mode 1 to mode 6, we will be getting the value, the waveform as like this. So VAO for mode 1, it is equal to plus Vs by 3, and for mode 2 it is 2 Vs by 3, and for mode 3 it is plus Vs by 3. For mode 4 it is equal to minus Vs by 3, and mode 5 it is minus 2 Vs by 3, and for mode 6 it is minus Vs by 3. With this, one cycle is completed. Again, the next cycle will take place. Similarly, we can draw VP1, VCO. So these three waveforms, the first that is A waveforms, the waveforms of A part, they are the phase voltages. We can draw the line voltages also. VAP can be drawn as uh, VAB, we can write it as VAO minus VPO. So if we subtract the VPO waveform from VAO waveform, we will get VAP waveform. So VAP for mode 1 will be equal to, this is plus Vs by 3, minus of minus 2 Vs by 3 will be equal to Vs. So for mode 1, VAB will be equal to plus Vs. And for mode 2, it is 2 Vs by 3 minus of minus Vs by 3, which is again plus Vs. And for mode 3, it is plus Vs by 3 minus Vs by 3, so it is 0. And for mode 4, it is minus Vs by 3 minus 2 Vs by 3, so it is minus Vs. And for mode 6, it is minus 2 Vs by 3 minus Vs by 3, so again it is equal to minus Vs. And for mode 6, it is equal to minus Vs by 3 minus of minus Vs by 3, which is equal to 0. So similarly, we can also draw the waveform for VBC, which is nothing but VBO minus VCO, and VCA, which is equal to VCO minus VAO. Now we can obtain the Fourier series expressions for the line voltages VAP, VBC, and VCA. If we derive the Fourier series expansion, we will get VAB expression as sigma n is equal to 1 3 to infinity 4 Vs by n pi cos n pi by 6 sin n omega t plus n pi by 6. And for VBC, we will be getting the Fourier series expansion as sigma n is equal to 1 3 to infinity 4 Vs by n pi cos n pi by 6 sin n omega t minus n pi by 2. So phase difference between this voltage and this voltage will be 120 degree. And VCA will be sigma n is equal to 1 3 to infinity 4 Vs by n pi cos n pi by 6 sin n omega t plus 5 n pi by 6. So, so far we have seen the 6 modes of operation of three-phase inverter, and we have drawn the voltage, phase voltage waveforms and line voltage waveforms, and we have mentioned the Fourier series expansion of the line voltages. Thank you.